rtDown is an environment for reading and writing scientific documents. Instead of writing formulas in LaTeX, you write them in rtLA. By compiling the math, rtDown augments the paper with clickable definitions and warns you when you've forgotten to describe a variable. The compiled math can be used to generate figures. Updating the formula will change both the math output and the figure. We have two design goals. The first is to support authoring, reading, and making use of correct and reproducible documents with minimal authoring overhead. The second is to provide ecological compatibility, which means we don't want to change or restrict what authors put in papers, such as prose, math, figures, and tables. And we want minimal changes to how they write. For example, we prefer plain text documents. To inform our design, we thoroughly analyzed 156 papers from the SIGGRAPH North America 2020 technical papers, collecting both quantitative and qualitative observations. We designed rtDown based on the previous formative study. Authors must declare context for their symbols. This allows better symbol and formula reuse. One appearance of a symbol in the prose deserves special attention: the text describing the symbol. Detecting the span of this prose cannot be accurately automated, so we require authors to annotate such spans. Authors can write executable mathematical expressions in different rtLA blocks and inline rtLA formula. rtDown executes Python code blocks, which allows authors to generate figures programmatically. rtDown helps authors write correct math and complete prose. The editor displays the rtLA compiled error message and highlights the appropriate line in the source. When symbols are not described with prose, they appear with red underlines in the viewer. rtDown's paper reading environment provides several useful interactions that use the metadata. rtDown displays the glossary on the right side of the window in a fixed position as the page scrolls. The glossary in rtDown is context-dependent. When the page scrolls to a different context, the glossary updates automatically with a relevant symbol list. This figure shows the visualization we provide when clicking on the symbol in an equation. When clicking an equation, rtDown highlights the terms involved in symbol's definition, as well as downstream uses of the symbol. For the implementation of rtDown, this figure shows the overall structure. We converted a variety of SIGGRAPH papers and paper sections to rtDown. Out of the 14 papers we re-implemented, we only found code online for 7 of them. Each example in our evaluation included rtDown source file, rtDown's generated paper reading environment, and rtDown's generated code library. We also provide a link to the original paper for comparison and side-by-side screenshots. We conducted an expert study. The first expert wrote a function with conditionals to calculate the distance from hand to shape in 3D. The second expert solved an optimization problem for 3D snapping. The third expert wrote a tutorial for discrete elastic rods. 2 participants appreciated that writing in rtDown is similar to writing Markdown. 2 commented that writing math in rtLA is harder than with Markdown or LaTeX. 1 commented that the generated code compensates for the additional time spent writing the equations. All participants liked the dynamic reader features. One limitation of rtDown is that it does not consider pseudocode. Another limitation stems from the kinds of formulas that our extended version of rtLA can handle. In conclusion, rtDown is a low-overhead, ecologically compatible document processor. rtDown supports authors and improves replicability, readability, and experimentation. Participants in our expert study found uses for rtDown in their research practice. rtDown can be used at all stages of research, from experimenting with the seed of an idea to writing the final paper. Thanks for listening. Please try our language. You are welcome to contact us in the future.